radicals in context. So basically what you're going to do on here is the first thing that you always want to make sure that you pay attention to with this is your units of measurement. Okay, so you need to make sure that they're consistent throughout. If they're not, then you actually need to convert it. So it says on Earth, the distance d in kilometers that one can see to the horizon is a function altitude a in meters and can be found by using the function d of a equals 3.56 the square root of a. To find the corresponding distance to the horizon on Mars, the function must be stretched horizontally by a factor of 9/5. If someone is at an altitude of 100 meters, what is the distance to the horizon on Earth? Okay, so let's start with that one first. Okay, so the first thing I always want to do is I want to make sure that I write down the formula. Okay, and then it tells me that I have 100 meters, and altitude is actually measured in meters. So we got 3.56 square root of 100. Okay, and then it wants us to solve for d. Okay, so we're going to have 3.56 times the square root of 100, which is 10. Okay, which if we multiply that out, we're going to get 35.6. Now, one thing though, this is already measured in meters, and our distance is measured in kilometers. Okay, so we need to make sure that we move this to kilometers. So remember back in the day when your teacher did the whole King Henry died by drinking chocolate milk, and this is where meters actually lives, but we need to get to kilometers. So that's going to be 1, 2, 3 units to the left. So that's going to be 1, 2, 3 units to the left. So that's going to be 0.0356 kilometers. Okay? Okay, so now we're going to actually find the distance of the horizon on Mars. And it says that you have a factor of 9/5. So what you're going to do here is you're actually going to take the original function. Okay, so d of a equals the square root and 3.56 is up front. And then you got a here. Okay, when it says that you're going to stretch by a horizontal factor of 9/5, what you're going to do is you're going to take that 9/5 and you're going to flip it. So that's going to be 5/9. And you're going to take that guy and you're going to plug him right in front of that a. So you're going to do 3.56 square root of 5/9 a. And then you're going to go into here and plug in 100 into that equation. So you're going to have 3.56 5/9 times 100. Okay, and you're going to plug this junk into your calculator. So go in here and you're going to say, hey, 3.56 square root of 5/9 times 100. And that's going to give you 26.53. 26.53. Okay, so this will give us 26.53. Now remember, we need it to be in kilometers because that's what they want us to write it out in. So we're going to move this 3 units to the right, or the left. So this is going to be 0.02553 kilometers. Okay. On number 2, it says, special airbags are used to protect scientific equipment when a rover lands on the surface of Mars. On Earth, the function is this. Approximates an object's downward velocity in feet per second as the object hits the ground after bouncing x feet in height. Okay, the corresponding function, Mars, is compressed vertically by a factor of 3/5. Okay, so what you're going to do here is you're going to take the original function, and this is compressed vertically. So you're going to take this 3/5 and you're going to throw it out front. And that is what our function g is. Now we're going to use that in order to estimate how fast the rover will hit Mars' surface after it bounces 45 feet in height. So we're going to take 45 and we're going to plug it in for x. And then we're going to go into our handy dandy calculator. And we're going to say 3/5 square root of 64 times 45. And that's 32.2. 32.2. So we're going to get 32.2. And this is measured in feet per second. And the way I know these units is actually looking back into that problem. That's why I have that stuff highlighted. Okay? Alright, so on this tic-tac-toe board, you're supposed to basically pick a couple of them to do. So I'm going to do a few of these. Okay, so I'm going to do this first one. It says the speed of sound in meters per second is described by the equation S equals the square root of 286 ht, where h is the ratio of the specific heats and T is the temperature in Kelvin. Find the temperature when S is 340 and H is 1.4. Okay, so we're going to take the original function and we're going to plug in what we know. We know H is 1.4. We don't know T, and we know that S is 340. Okay, so now what we're going to do is solve. So we're going to square both sides, and that's going to give us 115,600 on the left-hand side. So that's going to give us 115,600 on one side equals 286 times 1.4 T. Now we're going to divide by 286 times 1.4 in order to get T by itself. So we're going to go into our calculator and we're going to go and say, I'm going to get rid of all of this next. And we're going to say 1,115,600 divided by 286 times 1.4. And that's going to give us 288.71. 288.71. So T equals 288.71 Kelvin. Okay? Alright, so looking at C, skip it around. Looking at C, it says the Beaufort number B for the Beaufort wind scale can be modeled by that function, where S is the speed in miles per hour of the wind. Find the wind speed that corresponds to the Beaufort number B equals 7. So you're going to take the original function, and you're going to plug 7 in for it. I'm going to add 3.49 to both sides. And so that's going to give you 10.49 equals 1.69 square root of S plus 4.45. Okay, I'm going to divide by 1.69 on both sides. And so I'm going to go into my calculator and I'm going to say 10.49 divided by 1.69. and I'm going to square that. And the reason why I'm going to square it is because the next step would be to get rid of that radical. So down here, I would get 6 point something something, and I'm going to square both sides to get s plus 4.45 by itself. So again, that's going to give you 6.2. So 6.2, and then I'm going to square it. So that's going to be 38.5253. And then we're going to subtract 4.45. And so S is going to equal, I'm going to flip here, subtract 34.08. And that's measured in miles per hour. Miles per hour. Okay? Alright, so we're going to go through I really quick. So down at the bottom, it's got this problem that says one way to determine a person's BSA is to use that formula, where W is the weight in pounds. Sorry, I always highlight my stuff. H is the height in centimeters. And then it tells us that this dude, Gustav, is 160 pounds and then has a BSA of a 2 square root of 2. So, I'm going to plug in 2 square root of 2 for BSA. For my weight, he's 160. My height is H. And I got 3,600. So, in order to solve, I'm going to take this, square it, and square it. And this will give me 4 times 2. And you can plug this into a calculator if you're unsure. Just make sure you put parentheses around the whole thing. So that's going to give me 8 equals 160H divided by 3,600. And so now I'm going to multiply by 3,600. These will cancel. And I'll get 160H on that side. And then I'll plug this into my calculator and I'll get 8 times 3,600, which is 28800. So 28,800. And I'm going to divide by 160 on both sides. So that's going to give me, 180. That's going to give me 180 in height. Okay. Right. So, your teacher will have the rest of that answer key posted later on today. Your job is to try this problem. Okay. And you're actually going to find out that this is more common than you think. You'll pause the video and try it, and then I'll have the answer in just 1 second. So if you solve this out, you're going to get 125 feet for the amount of skid that this person created. So one way they could have proved it is if they measured the skid mark, because that'll tell you if they're going 55 miles per hour or not. So hopefully this helps, and maybe you want to go into forensic science and help out with car accidents. All right, see you in the next video.